Hi, I'm going to start off by showing number one. And the tactics we're going to be using today are fewer number pieces, fewer number of smaller pieces, and greater number of larger pieces. And as you can see, I already have the model here shown. Here we can see 7/11ths. Here we can see 7/11ths. And from what we can see about 7/11ths is that there seems to be more than half. And as we can see from over here from some side math that was done, half of 11 is 5.5. And so to me, that means that 7/11ths is more than half of our lovely little 11. And what I want to show, so this means that there's a greater number of larger pieces compared to the smaller number of smaller pieces, the fewer number of smaller pieces. And as seen here, half of 13 is 6.5. And because we learned that half of 11 is 5.5, and we have 7 pieces right here, we can already tell that 6/13 is going to be less than 7/11, because we know that 6.5 is half of 13. So that's number one. To preface that just because we have a larger denominator in one of our fractions does not always mean that this fraction is going to be larger than the other one, which is why we can do another way, which is making sure that another way to check is to make common denominators and then compare the numerators from that point on. But I'm not going to be showing that method. So moving on to number two. All right, here's our number two. So in this one, I'm going to explain how to solve 2/3 multiplied by 9/8. And this is our incomplete array model. I will be filling it in as we go. So this is technically our whole right now. All right? Excuse me. We have 3 columns here. 1, 2, 3. 1 column, 2 column, 3 column. Right? And that is because of our lovely 2/3. And we have 8 rows. Technically, we have 9 rows, but that's because this is an improper fraction. Well, it's 9/8. And what this does is it gives us this extra, not so extra row, because the 9 is still a part of what we're multiplying, even if it is an improper fraction. And as we know, a simple way to solve this would be just to, multiply the numerators and multiply the denominator. So it would end up being 18/24, which then we could reduce because both of those are divisible by 3. So that's 6 and that's 8. That's divided by 3 and then divide by 2 to get 3/4. This is what we're aiming to get by using this array or this area model. So I'm going to start out with using a different color. So we are going to show our array or area by shading in two columns. So we're going to shade in two columns to show 2/3. So let's do that now. Two columns have been shaded in. And now we're going to show 9/8. To do that, I'm going to use blue. And how we do that is we count how many eighths we need. This is an eighth, and this is an eighth, and so on and so forth. So 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8, 8/8, and 9/8. The whole row is filled in. And switch to another color. What we want to get out of this, from what we can see, what we're going to do is we're going to count how many squares are intersecting. What I mean by intersecting, or I mean overlapping. So where there's blue and there's pink. So we're going to count this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So right now we have our numerator. Our numerator is 18. But we need to know how many pieces there are in total. And a good way to do this is to count all the squares again, but every single square this time. So 1, we already know that these squares are 18 squares. So let's just count the squares that we haven't counted. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And what we can do from there, 18 plus 9 is not 24. Hold on a second. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Oh, that's right. Silly me. The whole is this. This is our extra 8. This is our 9/8 bit. And this is our 8/8 bit. So this is actually out of 24 and not, what is it? 18 plus 9 is 27. It's not out of 27. So we're not adding that. We're only adding 8. So 18, no, we're not. 1, 2, 3, 4, 5, 6, 7, 8. Am I doing my math wrong? Let's rethink this for a second. Three, 6, 9, 12, 15, 18, 21, 24. Yeah, so 3 times 8 is 24. And in the whole, there's a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Right. In the whole, there are 24 pieces. But because we have this cute little 9/8, we have these extras. Because if we were to just do these ones, these parts of our our whole, our 8/8 are 1, we would only have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We'd only have 16 pieces, which would not be correct. So, because we have 24 in our whole, in our area, this is our area, we have 18 because of these two down here. So our denominator is 24, which then we can divide by 3 over 3. And in this case, no, let's not do that actually. Let's just reduce it. We know that 18 and 24 are both divisible by 3. So 3 goes into 18 6 times, and 3 goes into 24 8 times. And then from here, 3 does not go into 8. So we have to go to 2. 2 goes into 6 3 times, and 2 goes into 8 4 times. So our answer is 3/4. And from the looks of it, 3/4 of our model has been completely filled in, because this part right here is our 3/4. So yeah. Okay, moving on to number 3. I'm going to do this part in sections, so there may be cuts here and there. So what we have here is our fraction, right? And we're answering A right now. So how do you see 4/5? Right now, I see that this is our whole with 1, 2, 3, 4, 5 pieces. But the thing is, only 1, 2, 3, 4 of them are filled in. So I see 4/5 in this by seeing 1, 2, 3, 4 pieces of our whole, which is 5, um, visible. So the numerator is represented by these 4 squares, and the denominator is represented by the whole, which is 1, 2, 3, 4, 5. 5 pieces. And the 4 pieces, the 4 orange squares, is the numerator. Alright, and now on to B. So our question is, what is 3/4 of 4/5? And what is the value and how do you see it in a picture? So when I'm seeing 3/4 of 4/5, it makes me want to think of, let's take a little bit of this actually. So if I wanted to see 3/4 of 4/5, we could use this as our whole. Or, even better, we could use this as our whole right now. And in this, I see 1, 2, 3. This is our numerator. And our denominator is represented by the whole. 1, 2, 3 fourths, because it is divided up into 4 pieces. And 3/4 of 4/5. Let's actually do that math really quick. So we'll bring B down here. What is 3/4 of 4/5? So we're going to take our image again, and we're going to make an image of our own. Oops, too short. Let's try again. That's ugly. Oh my goodness. We're making an image of our own. Why does it keep doing that? That's kind of annoying. Anyway, here's our image, right? We're gonna break it up the same way. 1, 2, 3. So like, this is our 3/4, right? And we'll color it in. 1, 2, 3. And another really important thing to remember about fractions, like fraction multiplication, is that when you multiply fractions together, you're actually making the fractions smaller. So looking at this, we can do, right now what we can see, we can really just kind of like move things up, and we can say, oh, 3/4 of 4/5 is, let's actually do that math really quick. 3/4 times 4/5. 3 times 4 is 12, and 4 times 5 is 20. And we reduce that by dividing by 2. So 6 and 10, divide by 2 again, and we get 3/5. 3/5, right? So honestly, yeah, I was right. You really can just move these up here. 3/4 of 4/5 is 3/5. So you really can just take this, oops, you really can just take our little model that we made and put it right on top for this specific example. And that's what I will say for this one. That's how I see 3/5, 3/4, sorry, 3/4 in 4/5. For this next section, we're going to be asking, what is 5/4 of 4/5? And how do we see the value? And what is the value, and how do you see it in the picture? So let's do one of these, because this is the same as up there. So what is 5/4 of 4/5? Right now, looking at it straight away, I can see that this is our whole for 5/4. So if our whole is this right here, and we have an extra fourth. So to me, that just means that this is already 5/4. But we really want to know, what is 5/4 of 4/5? So let's do some quick little math rooney. So honestly, no. That's actually a really easy question to answer, because if we do the math, it's actually really easy to see. It's 20 over 20. which equals 1. Any number over itself is equal to 1. So, really, like I said earlier, this is our whole, and we have this cute little extra. But when we have 5/4 of 4/5, it's just 1. It's just this entire thing right here. It's just 1. So that's actually quite simple. All right, and for our final problem, our question is, what is 1/8 of 4/5? So bring it on down. And how do we see it in the picture, and what is the value? So to answer the value question, let's again do some really simple math. 1 times 4 is 4, and 8 times 5 is 40. But this can be reduced down to 1/10, right? So this is what we're aiming to really see. But I think the only way that we can like truly see 1/8 of 4/5 is really making another bar. And so let's make another bar. That's not the same length. There we go. And we're gonna break it up into 8s. So this is, we can do 1, 2, 3, 4, which is 5, then 6. Ooh, I don't get that. Let's actually delete all these. Let's try again. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. Okay, so I already have everything set up down here. And so we're going to do some filling in down here. But we're answering what is 1/8 of 5/4. And coming down here, we see that I've solved it right here. So 1 times 4 is 4, and then 8 times 5 is 40. But then reduce down because 4 over 40, those numbers work really well together. And we know that 4 times 10 is 40, so it reduces down to 1/10. But what we really want to see is what is the value and how do you see it in the picture? This is our value. This is what it is. This is the answer to this problem right here. And for us to see it in the picture, we really have to look at what 1/8 is compared to 4/5. And I think a really good way of doing this is actually making the fractions equivalent. So what we're going to do is break them, we're actually not, I don't want to break them into 40ths. Let's think. How would we see 1/8 in this picture? Honestly, the only way that I can really think about it is just breaking it up like I did. So 1, 2, 3, 4, 5, 6, 7, 8, 10. That's 10. Don't want 10. We want 8. So right now we have 5 pieces total. That's 6, 7, 8. Just pretend that they're all the same size too. Um, from this is our 4/5, so but then coming up over here, this is our 1/8. Or we can put it over. No, let's put it over like that. This is our 1/8. And this is genuinely how I see it within the picture. So yeah. Moving on to our self-assessment. After completing the problem, reflect. How confident do you feel in your solution self-complete or your justification? The only ones that I'm feeling like really not so sure about is most likely D of number 3 and possibly these two. I mean, I feel like I explained it pretty well and I already had like the thing drawn out, as we can see from up here. I had this already prepared, both of these already prepared, but I did explain both of them and how the numerators correlate to the models that I gave. And I think I did a pretty good job explaining on how not just because the denominator is bigger doesn't mean that the fraction is going to be bigger. Um, but I think I did pretty well with the array model. That's actually the one that I'm most confident in. The only one that I'm not really confident in is D of 3. I'm pretty confident in all of the above though. So, thank you.